Hey pre-calc students, how you doing? This is it. This is the last section that we will do for the year. So we're here. Congratulations, you are at the end of the race. So before you give up, let's make sure we finish this one. This is putting it all together, this last section. Man, I really want to talk to you about lots of things, COVID, everything going on around here. Biggest thing I got to say right now is just, hey guys, I know you're young, you think you're immortal, and you probably are better than I am with my crutches behind me. But realistically, this is huge. I know we're itching to get outside and do it. Then go outside. But try again, limit your interaction. When your spheres interact with another sphere, those are more people that you're able to transmit to, or get the disease and then transmit it to others. So it's a lot more contagious than we thought. So do your utmost to really still adhere to that. I know it's hard. Believe me, my kids are just itching to get out. I am itching to get outside, and I'm laid up with these stinking crutches. So, all right, no more about me. My pity party's over. Let's get going. All right. So 9.8 systems of quadratics. Essentially, we are taking these quadratic relations that we've been doing, parabola, hyperbola, ellipse, or circle, and we are wanting to find where they intersect. So the book talks about the Earth here, and then if we had a meteor coming, and what's going to happen with that? Will that meteor come on? Will it intersect with our path around our elliptical path around the Earth as it travels around the sun? And if this meteor's coming in out of nowhere and it's coming in, will it intersect our path with the gravitational forces from the sun? And astronomers are watching the heavens, so to speak, and they are seeing heavens, little h, heavens. Will we intersect that? So a lot more variables, but thankfully we only have to deal with our XY system, not an XYZ system plus any other variables that would factor it. So thankfully we only have to deal with that. It definitely gets more challenging as you get in the upper mathematics. So let's start with this. Now the one thing I like to do right out of the gates is kind of identify these. You'll note there's no XY term. We did that the other day. That's nice. There's no XY term. So we can immediately identify this. Different coefficients, same sign. This is going to be an ellipse. Differing signs, coefficients don't matter, but differing signs, this is going to be a hyperbola. Okay? So we've got an ellipse intersecting with a hyperbola. Now if you look at this, we can immediately look at this and go, I could use the elimination method. And I want to talk about that real quick. The elimination method is going to be your friend, but I'm going to also use a graphing calculator to help me out and use augmented matrices. But these are instructions. So in the book it may say something different. I don't care. This is what I want you to do, which is solve for system, solve for the solutions, and graph and verify the solutions. You can do this first, graph first, then solve, and then your graph, and they should match. I don't care if you graph first, then solve, or solve and then graph. It doesn't matter. These are buddies. They should work together. They should verify one another. So whether you like to graph first, then solve, and get a rough idea where it's at, or if you want to solve first and then graph. I'm going to go ahead and solve first. Okay. So if I were doing elimination method, I would see, okay, let me eliminate. If I were doing this, I would multiply this whole thing by 3. And then add that, and that'd be easy to go. Okay, so I'm not going to review that. If you use augmented matrices, you must have a square matrix. Okay, you must have a square matrix, and they must be identical terms. You can do it with an x squared and a y squared, but they must be a square matrix of the coefficients, not including the augmented portions. So don't use it if this term had like a y or an x and this one did not have a y or x. Cannot be done. All right. So elimination method would work as well. And the next problem we're going to do is elimination method if I've got time. Okay. So let me pause. I put this in my matrix here. I hit second this, and then I did row reduced echelon form. You remember how to do that. And I get this matrix here. Okay, what does this mean? Okay, I'm going to copy this down. So again, you shouldn't have to remind you how to do this. Okay, so remember, this is not x or y like we did in Algebra 2. This is x squared and y squared. So this mathematically means x squared equals 9 and y squared equals 4, which I have written here. And of course, solving for x, you get plus or minus 3, and solving for y, we get plus or minus 2. Okay? What does that mean? That means that these two graphs will intersect one another at the 4 total points. Kind of crazy to think about that, but I'll write them down real quick, saving time. Okay, so all the various combinations. This is harder when you have 4 of them, but these are all the various combinations of, actually, order matters, so actually we can't switch the order, so there you are, combinations. So, anyways, so these are the 4 points that these are going to intersect. I'm going to go and show all the work and the graph, so bear with me and I'll explain the work of how on the graphing. You've already done this, but I want to show you. Okay, so got all the work done. This one's ugly. Okay, how convenient though that the centers of both of these are at 0, 0. Okay, but this one's a little trickier. If you remember from up here, we divide every single term by 85. Okay, that's easy down here, but this one, remember this was 9 divided by 85. Okay, but I want to get that down in the denominator. I want to get all down in there. So I have to actually take the reciprocal of that because it's 9 divided by 85, but I want to force it down in all in the denominator, so I would take the reciprocal of that, and so 1 divided by 9 divided by 85, which is 85 ninths. Okay, so basically you flip the fraction. Remember, it's 9 divided by 85, but you want to put it down in the denominator, you have to flip it. Okay, so I want to take the square root of this and square root of this. Oh, they just didn't turn out very nice, 3.07 and 9.2, but that's okay. Now I have x radius of that and a y radius of that. Okay, the other one I divide every single term by 6. Okay, well those are nice, but again they aren't perfect squares, so we have to deal with some decimal approximates. Okay, so 1.73 and 1.4. All right, we know this opens in the x direction because this one's negative. So the one that's positive, that's the direction we open in. How to get the asymptote lines? Okay, 1.4 rise over run to 1.4 divided by that. Again, not a very nice number here. All right, so let's now take a look at the graph. So here's our graph. Went up 9.2, down 9.2, went over 3.07, went to the left 3.07. Okay, there's my Easter egg there. And then I did the asymptote lines next. I went up almost 1, but 0.8 and then over 1. So 0.8 is what I used. So I kind of went up 0.8 and then over 1, and then went up 0.8 and then over 1. You can see my little dot there. Did the asymptote lines. All right. And then I had to go to the left 1.73 and to the right 1.73. So from there, and then do my things. So if you're, just in case Mr. Weeks is making sure they intersect, we have to, oh, they didn't quite intersect. So maybe I'll make my dot a little bit bigger. Maybe my dot a little, nobody's watching here, so it's okay. Shh, it's okay. Okay, so now I made my solutions at -3, 2, and -3, -2, +3, +2, and +3, -2. All of my original solutions. Okay, we're going to do one more. All right. Okay, so this next one is number 10 in your book. I'm going to move up a little bit. Let's identify what these are going to be. Again, no xy term. So we've got this, this, and this. Same coefficients, same sign. This is going to be a circle. Differing signs. This is going to be another hyperbola. Okay. I left a space here. You can kind of guess what I'm going to do. All right. Can't use augmented matrices here because we've got not a square matrix with the coefficients. But this is quite nice right here, or quite nice right here, whichever variable you want to cancel. Maybe not. You got to think this through. This is the strategy of which one do you cancel? Because if you cancel the x's here, okay, that's great, but you're still left with the 6x. So you have to make sure you're careful on which one do you cancel. So on this one, I want to cancel out y, because if I cancel out y, then I'm left with all x terms. Okay, so don't immediately jump to elimination method and go, oh, this looks like the easiest. That's what we did in Algebra 2. But here we want to think strategy and go, which one is going to keep me with one variable, okay? Does no good canceling out x squared here, but being left with an x, a y, and an x. That's the point of elimination, is to eliminate one of the variables. Okay. Getting a little nervous looking at the time. So elimination method, multiply this one by each of the terms by 3. Okay. Carry that out, eliminate the y. You can see the work there. Now again, I want to find the x solutions that solve this. So using the quadratic formula here, this turns out to be 2/5 and -6. Okay, algebra 2 going on right here. All right, going to take these solutions and plug them back in. Which one? Your choice. I always choose the easiest one. Okay, so I'm going to choose this one. I plugged in this 12/5 in here. Get y squared equals that. Y squared equals -4.16. That's no good. If I take the square root now of both sides, this is going to be an imaginary number, so we don't have to worry about that. We're not in the imaginary system. Okay. This other one, plugged in -6, work that out and I get plus or minus 4. Okay. So going back here, this one's no good. All right. Okay. So my solutions, or in this case my points of intersection, are going to be -6, 4. And -6, -4. Let's prove it graphically. Okay, so I'm cheating here. I'm using a previous one. So here we got x squared here. This is typical. We're completing the square here, same that we've been doing. All right. So we know this is a circle with center at -3, 0, and has a radius of 5. Remember, this is r squared. Next one, we divide every term by 24. All right. 2 divided by 24 is this and this. Ugly ones again. That's okay. All right. Decimal approximates right here. Of these right here, I kept them in radical this time. Decimal approximates. So slope. Hey, that's similar to the other one. So now here's my graph. Okay, circle isn't that great, but it's good enough. So again, try to do your best, but this doesn't need to be perfect. Okay, only Christ is perfect. All right. So again, we've got a circle. -3, 0 is the center. Okay, and I often put my solutions before. First thing I do is put the graph up, and then I put my solutions on there, and so then I'm like forcing everything to fit to those solutions. Or you could do the opposite and graph it and get enough idea, and then kind of curve it more to get to that location. All right. So again, going back to the hyperbola, it opens in the x direction, so 3.5. So I went 3.5 out this way and 3.5 out this way. Went up 0.8 and over 1, so my asymptote lines, and then graph the red, and then the circle, as you can see. And then these, so notice there's only 2 solutions this time. There are not 4 solutions. You could have 1, 0, you could have no solutions. You could have 1 solution. It depends on the shape. You can have some where you might have a parabola and a hyperbola, and they could intersect at one location. So you could have maximum 4 solutions. You could have 3 solutions, okay? So let's say I had a circle that touched here and only right there. So I could have possibly 3 solutions if I had a circle that kind of curved in and touched here, here, and here, anywhere twice on this one and once on this one. So again, you could have 4 solutions. You could have, like with the previous one, you could have 1 solution. You could have no solutions. Okay, so if I had a circle in the middle here and they never intersected anything, so I have no solutions, 2 solutions, so maximum 4, minimum, no solutions. All right. So that's it for today. Again, during this Easter week, may the Lord bless you and keep you. All right. Have a great and wonderful day. Enjoy it. It's so nice outside.